Hey guys, welcome back to Data Wrangling with R. We're going to keep diving into this tidyverse, tibbles. And so last lecture we learned a little bit about how to kind of manipulate tibbles with the gather function. We're going to continue on to make you an expert in how to actually manipulate and make these tidy data sets. Alright, so we ended on spreading and gathering. So now we're going to we're actually going to do the spreading. So we labeled it last time, but we'll actually do spreading this time. Alright, so spreading is the opposite of gathering. Let's look at table 2. So if we were to run table 2 from the tidy data set, we can see that we have redundant information. Wait a second. Oh, yes. Okay. So we have redundant information, right? So we have country multiple times, 4 different times in column 1 for each of these countries. So Afghanistan has 4 different, so there's not one single observation in a row, right? We have 4 Brazils and 4 China. Okay. So you can see that we have redundant info in columns 1 and 2, right? So the same thing in column 2 where we have 2000, Afghanistan 2000 represented twice. So not tidy. We can fix that by combining rows 1 and 2, 3 and 4, etc. Alright, so how do we do this? So we use the spread function. So we're going to spread table 2, and our key is going to equal type. So if we look at this data, our key is going to be to spread based on type, and value, oops, don't want the console there, value is going to equal count. So the 2 that we don't want to spread, so we're going to spread these 2, right? So type and count. So if we were to run this, you see now we have Afghanistan 2000 or 1999 cases and population, because previously we had Afghanistan 1999, so we've combined cases and population right into a single one, or into their own columns, and so we've made it more representative of a tidy data set, right? This is the, let's annotate this. So type is the column or the key of what we are turning into columns, right? So key is asking for what you want to turn into columns. And so in this case, we said we want type to be each its own column, cases and population. Let's see. The value is what becomes rows. So our value is count. So this rows, I should say, observations. So we want these all to be their own observations in each row, right? So that's the value. So now we have, for cases, the observation that are unique to each country and year. Okay. Let's kind of summarize this. So in summary, spread makes long tables shorter. So previously this had, let's see, where does it say the rows? 12 by 4. So it had 12 rows, and now it has 6 rows, right? Because we've just created more columns. And shorter and wider. Gather makes wide tables narrower, and longer. So if we were to look when we did gather up above, we had, let's see, where's gather? Here we go. So we had a table that was 3 by 3, and we made it, well, I guess that one was 6 by 3. So it's not really narrower for this instance, but in general, they become narrower and longer if you have multiple, more columns than that. Okay, continuing on, let's do separating, and pull. Okay, so now what happens when we have 2 observations stuck in one column? So that was our last rule, right? So if we go back to our rules, which were up here a ways, each value has to have its own cell. But what if we don't have each value in its own cell? So an example of this is shown in this standard tidyverse data set where we run table 3. So if we run this, you can see in this version of the same data set, we have country, year, and then rate, which is the case number divided by the population, right? And so it's not tidy, because if you were to try to average, say you wanted to run average or the mean on the rate column to just see what the average case number is, you couldn't do it because it's messed up inside that 2 values in one data frame. So as you can see, the rate is just the population and cases combined. We can use separate to fix this. So let's do table 3 and then pipe down, separate. We're going to say rate, which is the name of the column head, and we're going to separate it into a collection of 2 variables, which we're going to call cases and population. So if we run this, perfect. So now we have country, year, cases, population, that tidy data set that we were trying to get previously. However, if you notice, column type is not correct. So if you look previously, we had character for country, integer for the year, which makes sense, and then character for the rate. Well, when we did the separate, we have character, integer, and it just takes whatever the previous column class was to make the new column class. But these are integers, right? Both of these are integers. We don't want them to be characters. So we can actually fix that. So make sure I find my right spot here. Table, let's do the same code, table 3, pipe down, we're going to do separate rate into the same thing, so cases, population, close it off, and then we're going to say, convert equals true. So convert these to whatever our intuitively thinks they are. So if they're numbers, they'll be integers, which we have here, just like year. One other thing I kind of skipped over. So how does it know where to separate? So this package, in the case of numbers, it will take any non-alphanumeric number or character. In this case, it's that the backslash here, and use that as a separator. But sometimes your data doesn't have that as a separator. It has something else, or for some reason a number is used as a separator or something like that. Or you want to extract just the last 4 digits from a number or something. So you can actually specify what you want to separate based on. So to do this, I'm just going to copy this code. And all you do to do that is type sep equals and then whatever you want your separator to be, right? So we'll say the separation is just on the slash, and you run it and you see it does the same thing. So intuitively, it will do it based on any non-alphanumeric number, but if you have to specify, you just use this separator command. Okay. Now, so now that we've added all this, let's make this look more tidy. So we want to kind of get in the habit of making our tidy data readable and look tidy. So we're going to do separate, and then we're going to go down to the next line. We're going to say year, and we're going to say into equals C cases. Oops, let's say populating last one. Population. And oops, gotta put a comma there. Let's see what I'm doing. Yep, comma. And then we're gonna say convert equals true. And then we're gonna say sep equals the /. You can also, so the other thing too I want to show with the separate thing, you can also put a number here. So you can say sep equals 2. And what that's going to do is that's going to separate based on the number of digits. So let's try it like this and see what happens. Unexpected. Where do I have an extra here? Separate. Oh, this guy have a comma here. There we go. Okay. So as you can see, it just took 2 digits. Oh, so this broke. I did year instead of rate. So what this did is I took the year and I separated it. So let's change this to century and change this to year and run it again. Okay, so now we have Afghanistan in the 19th century, the 99th year of the 19th century. That was our rate. And then in this year we have the why it dropped to 0, that's interesting. Year 0, I guess a double 0 it drops because it's an integer, the double 0. The 20th century, the 0 year, the first year. So yeah, so you can use decimal places too for this separate. Yeah, generally that's it. Like I said, it's not very useful in the grand scheme of things to separate the century into the year, or the century in the year, but just for S's and giggles, I guess we'll do it. So yeah, so that is the separate function. Okay, so we're getting through our tools here. We have a few more to go. But as you can see, it's nice, it's easy to do this in R. When I was first starting out, and when a lot of people first start out, if your data is not set up right, you're like, oh crap, and then you're like, oh, let me go back to my Excel file and, you know, change everything around so then when I load it, it's correct. Well, the problem with that is Excel files are easy to mess up, right? So, you know, it's easy to delete values and things like this, and it's hard to go back. You know, you can do the undo button, but if you've really messed up, sometimes the undo button won't save you. So this is a nice way to, you put your raw data in there and you do all these changes in here. The raw data never changes, so you don't have to worry about losing it. You can always modify your script and rerun it and save yourself the headache or heartache of potentially losing your data or messing up your data. So it's not that scary. You know, we're working through it. Small lines of codes. Tidyverse is real, you know, easy to understand, I think. You know, playing with it a little bit, you'll kind of learn the best ways to employ it. So that's it for this lecture. Man, this one's kind of been off the rails. Yeah, Isaac's agreeing with me. So keep working at it, and I'll see you in the next one.